Hello, welcome to the presentations about how printk got fixed for RT and actually other use cases in the mainline. It was a long journey. My name is Petr Mladek. I am working in SUSE Labs in our core team, and I'm also upstream printk maintainer. So, I will start talking about some history of printk and about actually what we'll try to describe what were the actual problems that we needed to solve. Then I will try to describe like the hardest problems that we were working on during all this 5.5 years when RT people tried to upstream their solution. Then I will show just some numbers about how many patches went in and so on, and dates. And then I will try to answer the question whether all this added complexity was worth it. And finally, do some overview of the remaining problems. So let's start about the history. So printk is part of kernel since the very beginning. It's the basic tool how to debug kernel. It's actually how the kernel is able to tell what's going on there. And the first solution was pretty easy, like that printk. I actually don't remember if it did store the messages, but it definitely like put them out on the console, either graphical or on the terminal or via a serial console out. And it got more complicated. Like over the years, it got fixed to work in more safe way, in more context, like in interrupt context, to work safe way with more CPUs when they started to be around. Then actually 10 years after the first release, there was added some interesting hack because of to work better with more CPUs, because before, like each CPU stored its message and then flashed the message immediately to the consoles. But for example, when there was attached a slow serial console and more CPUs printed the message in parallel, then actually all the CPUs had to wait for each other until they pushed their message on the slow serial console. So I was not there around the time, but I guess that it delayed, for example, the boot a lot. And so Andrew Morton added interesting trick that they use trilog in printk, and the one printk that got this log for consoles got responsible for flashing everything, even when the other CPUs edit messages in parallel. So this fixed the original problem and bring actually new problems, like that the one could spend basically unlimited time like flashing the messages when the other CPUs keep it busy. It was not actually the problem at the beginning, so it actually took another 12 years until this problem became visible. And actually, after the year 2010, there started to be many problems at the same time. One problem was that, and it was because there were started to be around machines with huge amount of CPUs, with huge amount of added hardware like hard drives, network cards, and so on. So, for example, during the boot, kernel printed a lot of messages, and the one who was the random victim CPU, which got responsible for flushing all these messages, spent too much time, and when it was in atomic context, that some machines even didn't boot because the CPU suddenly wasn't able to handle interrupts in time and so on. So this is actually when Jan Kara came up with the first attempt to offload consoles to work use in January 2013. And later attempts were like to offload them to K-threads, which is basically the solution which later wanted also RT guys, because for them, like handling consoles in printk directly is no way, because printk never know whether it's called in atomic context or in preemptible. So in atomic context, there is like no way, because handling console is too much work even on faster consoles, and like for RT it would be too long without possibility to schedule, and with serial console is like clearly no go. And so for RT they really needed to offload it like every time, basically every time. Yeah, and by the way, there were also another problems that appear after the year 2010, that, for example, at SAP, they found that some machines suddenly freeze without like any output, without anything. And it took actually a few months, and they had to attach some hardware debugger and so on to actually find out that the machines got into deadlock in printk for the log buffer in NMI, because it's non-maskable interrupt. So it interrupted even the code even when printk disabled interrupts when accessing this ring buffer, that they still tried to write there. And why was called printk in NMI? For example, to get out backtraces from all CPUs. So at this point, the NMI is pretty handy. And actually, why this happened about this time, one reason is that there were increased number of CPUs on the machines, so the risk of this deadlocks got higher. But also in 2012, systemd people added support to actually store the messages atomically. Before, the messages were stored like one character by character, so the log buffer lock was taken for a very short time. But after that, they really took the log for writing the entire message and for reading and so on. So suddenly the race window got bigger. And I'm actually not sure, but maybe there was added also the support to flush the backtraces using NMI and so on. So this is why all this like joined together. And actually the result was that actually the printk code, the printk got like worked better, because when more CPUs printed these backtraces or whatever, and these were mixed before like characters, then it was no way to actually sort them. When at least the lines were always consistent, then it was possible to later sort them. And system actually also added some sequence numbers and so on. And later we added even information about the color context, so it was even possible to filter like messages from given CPUs and really get the backtrack like together. Yeah. So anyway, like this complicated printk, and there were a lot of troubles. And actually, I took the task to upstream the K-threads from Jan Kara. But before I actually managed to start on it, then Sergei Senozatsky from Samsung also wanted to use the K-threads. And but they actually tried to use them at Samsung, and it actually blocked the development at Samsung for 3 days, because they pushed also user space messages through the kernel log, like when the user space any user space applications crash, then they put a lot of debugging information through kernel. Suddenly there were even more messages, so the K-thread was not able to keep up with this amount of messages. They were using them, and they actually were not able to debug, so they had to revert it. And then even Sergey was started to be afraid that maybe the K-threads are not the right way to go. So we were thinking about a lot of problems. And in the meantime, we work on workarounds for the other problems, like there were added like per CPU buffers for storing messages in temporary buffers for storing messages in NMI or in a recursive printk to avoid the deadlock in NMI and with recursion. There was added a hack to actually steal the console log from one CPU to another CPU and so on. So there was a lot of work which we were busy with. So the progress was really slow. And actually, some upstream people even didn't understand the problems, and especially Linux never did like offloading, because it brings the risk that nobody will actually see the messages when the K-threads are not scheduled. You won't see them. Of course, we try to switch to direct flushing in some emergency context, panic and so on, but it often didn't work because the K-thread had the lock and so on. So it was also not that easy. And there was quite strong pushback against this. But fortunately, in 2019, John Ognes from Linuxtronics sent the first patchset, which tried to upstream the RT solution. It was pretty similar what we actually had, like the attempt that me and Sergey put together. So we tried to explain John all these troubles that we had with it and that were around it. And it ended like just like half a year later. Thomas Leixner organized a meeting with Linus and other guys on Linux Plumbers, where we were discussing this, and we agreed to actually do the following, like implement lockless ring buffer, which would be ultimate solution for the deadlocks when accessing the ring buffer. It would work in NMI, recursive context, and there would be any troubles with these temporary buffers, and that the messages were lost when the synchronization didn't happen, and actually the messages were not synchronized against the other messages when they were added later, and so on. The buffers were sometimes too small, so the message was not complete, and so on. So the lockless buffer would solve all these troubles. We agreed to add per console K-threads that Linus give us, like that we could try it, and it would work the way that when the system is working normal way, then we could use the K-threads, and then we will mark some emergency situations like some lookups and warns and oops and so on, like emergency, and we will try like to switch this to the synchronized flushing of consoles, and of course in panic, because in these situations the system is in state that even the RT scheduling is not guaranteed. So actually getting out the messages and the message about what's going on is more important. Yeah, so this was the deal. So we started to work on it, and like just to give an idea, we had to implement new ring buffer. There was one for ftrace, but it supported just one reader, and there was no easy or reasonable way how to extend it, like by the design for more readers. And also like that systemd guys added sequence numbers, so each message has consequential number. So actually, for example, the journal is printing message that this amount of messages got lost when it's not able to read messages with some IDs. Actually, this probably would be possible to add to the f-tracing buffer. But anyway, we actually use the sequence numbers as part of the algorithm, as the lockless algorithm for like reserving the location and for synchronization that lockless ring buffers. So we actually use this as an advantage, like for implementation. And I won't not got too much into the details. There were actually two ring buffers, one for some metadata and actually describing also the state of the related data in the data ring buffer, and the data ring buffer was for the strings. And actually, there was fixed amount of this descriptors slots, which allowed to reserve this fixed amount of records in the data buffer, and they could be in 4 states like reserved, committed. Committed state actually allows to reopen, to go back to reserved state, and actually it was used for per cont, like for appending another string to the end of the last one. And the third state was finalized, so it was used for string that ended with new line, which didn't make sense to extend, or for all the messages that were not the last one. And only these finalized messages were like available for readers to see them. And of course, also reusable state. It was used for the records that were freed when the buffer was full, and we needed to make space like for the newer messages and release the last ones. And of course, synchronizations of all of this there were needed a lot of memory barriers and get overview about how all this works. So John actually invented even new format for documenting this. It was like, there are pretty long comments, like 15 lines or so for each barrier. It's and also like the related stores or reads has also a comment with some tag, which is used in the description. There is a human description describing what is supposed to be synchronized, and also some formal description that might be used even for creating litmus tests. And John actually did testing, and he was also running like a lot of tests on ARM when the memory is the synchronization internal memory is really weak, so like the strong barriers are needed. So he saw when some barrier was missing and it did blow up, and so on. So another big task was actually when we wanted to created the per console k-threads, then we actually wanted them so that they could work in parallel. And previously, everything was synchronized, but console log, which also historically synchronized a lot of other stuff, including even some code in TTI in the TTI subsystem, because historically, like like the first printk was directly accessing TTI and so on. And so actually at some point we decided to like to split the responsibility and make clear, split the console log and edit a lot of other logs for various tasks. And actually, for example, we also allowed to access the list of registered console in SRCU, which is sleeping RCU, which is a context when you are sure that the console registered still works. and actually it can be actually unregistered in the meantime, but actually the SRCU makes sure that like the unregistering doesn't finish and the device is not freed, the structures are not freed until when everyone is still using the console. Yeah. So there were like different logs for various read interface and dumping and so on. And also we created some special log at the end, and I'm going to describe it, which allowed like more safe actually and more reliable takeover, like flushing the messages in the emergency and panic context. It supports 3 priorities. One is used when the system is working normally for printk. Another one in emergency situation when the system is in troubles and probably doesn't work correctly, and we really want to get the messages out immediately, but the system will try to continue eventually. And finally, in panic, when like the system is going to die, so it's actually, and we are basically just one CPU is responsible for doing all of this. So then the log also allows like to take over the ownership for the lower priority context to a higher one, and it actually is able to distinguish when it's safe and when it's not. So for example, on the serial console, when you print the characters, then when you are like flushing then one character, then you are manipulating the serial device. So first you need to do few operations which has to be atomical, and when the state of the serial console is like not really consistent, so when it's not safe to take over. But in between characters, it's actually safe to take over because another CPU could just continue use this serial console for flushing another character, and so on. So there is an interface like for entering that unsafe section, and this callback this interface like function returns whether it succeeded or not, whether actually the context still has the ownership or whether it was lost when it was safe to lose it. And actually the code has to be ready that it doesn't longer has the ownership, and that actually the console was used and even the buffers were used by someone else in the meantime. So it has to basically bail out, and yeah. And also this log actually has the, at least for printk, it has the try log semantic that it might fail because the when the system is in troubles, that even the current owner might be in the unsafe section and might be stuck there. So we actually, even the emergency or panic context will not succeed in getting the ownership and won't be able to flush the messages the safe way. Just the final flush in panic actually tries to take the ownership even when it's not safe, and just try and pray that it will succeed. Yeah. So that's the log. Another tricky thing was that actually first I thought that this new log might be actually replace the original log that was used for synchronizing like the device, like for example the port log. But actually it didn't work from few reasons. Like first, the logs have different lifetime. Like the port log is available when the port get initialized, and when actually the struct port is allocated, the spin log is initialized, and it must be used actually for synchronizing also another operations with this device. Like serial port could be used for normal, like even like login, or you could log in over SSH and communicate with the messages, so read write. You could tune the speed or whatever. So you basically need this original device. We call it device log, like in abstraction, like we have to keep it. And because the new special log is connected with the struct console, and it basically gets connected with the device only when the device gets registered as to be used as a console, because there might be many serial ports and just one gets associated with the serial console. Yeah, so we basically had to create some wrappers around these two logs to synchronize them against each other. And this wrapper actually has to be used in all this device drivers code. Yeah. So here is actually the table about the rules, how the locking is supposed to be done in various contexts and in various parts of the code. Like in the device driver, we have to use the wrapper that is synchronized the device lock and eventually even the console context for all the operations. During the registrations of console, we have to also use the console list lock and the device lock to actually, because when we are registering that, at some point the console might start being used for another CPU by printk. So the device lock actually makes sure that the device is not used by anything else. So actually the other context, for example, in the emergency, which is synchronized by just this nbcon context, actually is not used, because during the registration there is small race window when like these two logs are not synchronized against each other. But it's actually done, the synchronization still using the device log. Then there is actually still the legacy code, because at the moment there are actually just two console drivers that are converted and support the new console log. And the rest is still using the original approach, and everything is synchronized by the console log, and everything was as it used to be. So in normal situation, like there is no change and we still have all these problems that we had. In RT, actually, there is an exception that even this legacy, we call it legacy loop, is also like put into the K-thread, because like handling the messages directly in RT is no way. So that's how it works. And this the last three lines are like for the used by the converted console drivers, like in normal console. It's actually the console driver has two callbacks. One is write thread, which is to be used in context when it can be even schedulable, and it actually must be schedulable in RT. And it's synchronized by both by the device log and the nbcon when the new console special console log. And actually the device log provides the RT-friendly locking. So it's, for example, it's the console log, which is a spin log normally, but in RT it's converted to mutex, so it could sleep. And the advantage is that actually the mutex is also handling in RT the problems with inverted scheduler priorities. So for example, when the current governor has low priority and the new waiter has higher priority, then it would normally have to be blocked for a long time until this low priority task gets scheduled and could release the mutex. But in RT, and maybe even in normal system, like the current owner inherits the higher priority, it's scheduled sooner, and actually is able to release the mutex faster. And the nbcon context, the new nbcon context log is needed, because in the emergency and panic we use just this log to be synchronized, and we actually know that when we acquire it, there's nobody else is using the device, and just the final panic call is trying to acquire unsafe that it tries hard way. Yeah. If you are interested into numbers, then like it took like 9 months to implement the ring buffer. Like for example, the first attempt was much more complicated than the later. We make it simpler and simplified it a lot. And actually the interesting thing is that we added the buffer and we still keep still keep the log buffer log. So this reduced the possible amount of regressions that could happen, because it was a lot of new code, and we didn't want to. If printk did blow up, then everyone would be like really angry about us. So we wanted like to rule out races and just sort of possible miscalculation or buffer overflows or whatever caused by mistakes in the counting. And later we added also a few missing features, and finally removed the locking and removed the temporary buffers and so on. So it took another year until we fully integrated it, log buffer log, and used the full potential of it. Yeah. And it took another 3 years until we added the k-threads. There were actually 2 attempts. One was that one was without the special console log and without a lot of cleanup. When we just replace, we added like just mutex into struct console, and we somehow synchronize it against the console log. And we actually got this code into the main line, but it did blow up because, for example, we were not aware that boot consoles were not synchronized using any log, because even, for example, the port log doesn't exist when the early console code is used. It just accesses the serial port directly, and it just some minimal initialization and start using the device without any locking, because like the device infrastructure is not ready at the moment yet. So it did blow up from this reason. Also, there were a lot of situations in panic or in emergency situations when the takeover didn't work properly. So it did kind of blow up in the RC phase, and we decided to revert it. And actually, Thomas Leisner came up with the idea to actually convert consoles one by one and add this special log to make it like more predictable, the takeover and so on. And we fixed a lot of stuff, and we really cleaned up the responsibility of the console log and so on. So it took all this time. But finally, in like September last year, like the last piece was added, and it works. And one interesting stuff is, for example, the last but one patchset, it needed a lot of revisions. It was because when we added the callback for flushing in the atomic context, then suddenly there were so many possibilities what printk has to do, whether to call the legacy loop, whether to wake up the k-threads, and whether to flush directly, and when there are these boot consoles and no, and so on. And this actually logic was not just in printk, but it was also in the panic code, and when suspending consoles, and when CPU hot plug and so on. So we had to somehow make a helper function which could do the right decision in all the situations and somehow make the code maintainable. So it took us few iterations to get there. Yeah, so, and whether it was worth it, so I did ask this many times because it was a lot of tricky code and a lot of complexity. And yeah, I'm not even sure if we would be able to get it in if it wasn't like Thomas Gleixner and his like push to get RT in. But yeah, if we wanted to fix RT and also the other use cases like big machines, then I think that this was like needed because the simple offload to K-thread was not acceptable and didn't work well. And if you look into more details, then the lockless ring buffer solve like all the troubles with deadlocks and these temporary buffers and so on. It's a complicated, tricky code, but it just works. And it's there already like for years, and I have to knock on wood, and it didn't blow up. Like there were some problems with like with the speed when someone allocated too big one and so on for reading, but nothing really big. So I think that it was worth it, and I believe that it might survive. Splitting the big console log responsibility, I think that it's great way because there were even historic attempts to get rid of it in the TTI code and they failed and so on. So I believe that this was the right way, great things to do. Regarding the special console log and the device log, like the code and all these dependencies are kind of maybe too tricky. And sometimes I'm not completely sure whether it's worth it, but like theoretically it should work really great, but the code is still too young and there are still just 2 drivers that are actually using it. And even the most common like a serial port that UART 5082 is the patchset exists, but it's still in Linux Next because several reasons. For example, it like in the K-thread, it doesn't longer touch the watchdogs because it could sleep. It doesn't need to. Like there is because printk did cause soft lockups. So it actually included the code to touch watchdogs, like to don't warn about the soft lockups, because it was known that it could cause these soft lockups, and actually there was no way around, no way around. But this kthread don't longer does it, and some code actually relies that printk, another code cause soft lockups, and it was not seen before because printk did touch the watchdog for this code. So it was hidden and suddenly it's visible like this. Yeah, and stuff like this. Yeah. And yeah, so that's about it. And last thing is like this per console K threads. It's another complexity. One K thread for everything would be easier, but I think that actually splitting, like introducing more logs and having like log per console driver helps, like to avoid this big console log semantic and like make the life easier in the long term. And even it's great, like when, for example, you might see the messages faster on graphic console and on slow, while the slow serial console is still like slowly showing them and so on. And when the some console driver gets blocked, then even the others might get the messages out and so on. So I believe that this is good as well. So, but let's see. I think that the real check will be when the UART 8052 driver gets converted, and because it's the most commonly used serial log, and then we will really see how people feel about it in the normal kernel. So let's keep our fingers crossed. And remaining problems, yeah, like we still need to obviously convert all the existing console drivers to support this new console log, which includes actually reviewing all the synchronization of all these operations on the device and using the wrapper that's synchronizing the device log and the console content logs there. And sometimes we find that it's missing. So it's a good opportunity to actually double check this and fix existing troubles. Then the owner has to implement 4 callbacks for structured console, like for taking the device log, so that it could be used for the console registration and console for the K-thread. And then these 2 callbacks, like one for flushing messages in the preemptible context, and another one which is supposed to work in atomic context, including NMI. And yeah, and actually in these 2 callbacks, they have to use this Nubicon unsafe enter-exit to switch between the when the takeover is safe and not, and especially the slow drivers should do this between each character ideally, so that actually the emergency or panic is able to take over the ownership in time before the timeout and so on. So that's it. Yeah, there is also printk deferred, which I didn't mention, but it's special variant of printk which explicitly disables flushing consoles, and it's currently used in scheduler code and in timer code because of the console log. It's sleeping log, so when printk releases it, then it calls wake up process when there is some process of waiting for the sleeping log, and the wake up process takes the scheduler log, and I'm not completely sure if the timer log is still problem at the moment. I should maybe like review it. But anyway, like we eventually might not need this when all the consoles are converted. But my estimation is that it might take another 10 years until all consoles are converted and until we get rid of the legacy loop and console logs. So maybe it's like it would be nice to get rid of this printk defer, because we edit when something like breaks, and people find that this printk can cause deadlock, and which is bad solution. It would be nice when there are wrappers around this scheduler logs which actually enter the printk deferred context when this log is taken, so it will always will be safe, and any printk when this run q log is taken will just defer console handling. Yeah, but I would need to convince maintainers, and of course there are still many ideas what to do with printk, like per console log levels. And recently there is the people point out the problem that when there is huge amount of machines, like millions of them, and they report some hangs, or so this, for example, hang task report, they have hard times to actually find all the related lines, then they don't know where the report starts, when it ends. Also, some lines have different log levels, so they might be even missing because less important messages with less important log level are filtered on slow consoles or on consoles, and so on. So, and some cleanups and stuff like this. So still a lot of fun compare, but I think that it's a big relief that the K-threads are there, and yeah, it seems that it somehow works. It didn't blow up yet, but yeah. And it actually basically this started in 2012, and it took like 12 years to get this in. And yeah, okay. So that's it.